Hello, good afternoon. So today we'll look at the first part of kinematics. So this will be the first part, and then also do a second part and the third part. So kinematics part 1. Okay, so whenever you're looking at kinematics, we all know that we are just simply looking at the study of motion. So under kinematics, our main focus will be studying what motion is. And we all know that anything that involves motion involves a change of position of any given particle with respect to time. So anything that is changing position with respect to time is undergoing motion. Now this same motion that we are looking at can be divided into three categories. We have motion that occurs in one dimension. We also have motion that occurs in two dimensions. We also have motion that occurs in three dimensions. Now, if you remember what we did under vectors, we said if anything is moving in one dimension, then this particle is either moving in the x or in the y axis. And if anything is in two dimensions, meaning this particle is neither moving in the x or in the y. So meaning it's in between the x and the y axis. Then for 3D now we have three axes, which is the x, y, and z. So just remember to say motion involves the change of position with respect to time. So in part 1 we'll focus mainly on 1D, where we consider this particle either moving in the x or in the y axis. Okay, so what are you supposed to know about motion in 1D? So whenever a particle is moving in 1D, so you're saying it's either moving in the x or in the y axis. Okay, so we'll divide 1D into two parts. So the first one will do motion in 1D involving the x. Then the second part will do 1D involving in the y. That will be referred to as your free fall. So particularly today we are just focusing on 1D in the x axis. Okay, so whenever something is moving in the x-axis, from our grade 12 physics, we should be able to know a number of definitions, such as the definition for distance, displacement, velocity, and all that. But here, my main focus, I want us to pay particular attention to a definition of instantaneous velocity and acceleration. So you should know how to define these two terms in addition to the other terms that you did in grade 12. So how do you define instantaneous velocity? So from the word it's saying instantaneous velocity. So this refers to the velocity at a particular instant. It refers to the velocity of a particle at a particular instant. Now, whenever I define an instantaneous velocity, we are saying instantaneous velocity to be given by the limit as t approaches 0, a small change in the displacement over a small change in time. So we are saying instantaneous velocity is the velocity at a particular instant, which is given by v is equals to the limit as t approaches 0, dx over dt. So what you are noticing is that the t is approaching 0. Why? From the definition, since we are saying instantaneous velocity is a velocity at a particular instant, so therefore the value of this t is going to be very small to an extent that the t will be approaching 0. It's like if this particle is moving from point A to point B, and then they ask you to find the velocity of this particle at point B. So mean the velocity at point B, the time that you're going to get is the time between point B and point B, and that time is going to be very small. That's why you're saying your t is going to be approaching 0, a small change in x over the small change in time. So v is dx over dt. So dx simply means a very small change in the displacement and a very small change in the time. That's why the t is approaching 0. And then same applies to instantaneous acceleration. It will be given by acceleration limit as your t approaches 0, a small change in velocity over a small change in time. So from this now, we'll be able to come up with a relationship saying whenever I'm moving from velocity to the displacement, I need to find the differentiation of the displacement to give me what my velocity is, and the differentiation of the velocity will give you what your acceleration is. So this simply means if you have your x, you also have your v, you also have your acceleration. Whenever you're moving in this direction, all you need to do is you have to differentiate. So once we differentiate the expression for x, you find for v, and once you differentiate an expression for v, you find for a. So that's why if you notice, for you to find a, you need to differentiate the expression for displacement 2 times. So that's why this can also be given as the second differential of the displacement over dt squared. So this simply means if you have to go the other direction, you have to integrate. So here we are integrating, even here you are integrating. So this will be very important when you start looking at questions. You're supposed to know that whenever you're moving from x to v, you differentiate, from v to a, you differentiate, and then from a to v, you integrate, v to x, you integrate also. Then the other thing that you're supposed to know are the equations that we are going to be using under 1D motion in the x-axis. So mainly there are 3 equations that we are going to be applying. So the first one that you're supposed to know is v is equals to vo plus 80. Then the other one is x is equals to xo plus vo t plus 1 over 280 squared. And then the other one will be given by, let me just write it here. The third one will be v squared is equals to vo squared plus 2ax minus xo. So you're supposed to know these equations, know how to come up with these equations using algebra or calculus. So this is what you're supposed to know in the introductory part of kinematics. So in the other part, we can now do questions involving what I've already talked about.